All right, guys, we're on day 2 notes of Unit 8, and we're going to talk about completing the square. And this is another method to find the roots or the zeros or the x-intercepts if you cannot factor the equation that you're given. So it says some quadratics have real irrational roots. This means that the function crosses the x-axis at the roots. This means the function crosses the x-axis since the roots are real, but crosses at x values that cannot be written as fractions of integers since they are irrational. Some irrational roots can be found by factoring and solving, but some cannot be found this way since not all quadratics are factorable. So this is try finding the roots of this equation. And so we know that our first type of factoring that we look for is greatest common factor, and there is a greatest common factor of 2, so we're going to pull it out and be left with x squared minus 6x plus 7 equals 0. And then we got a nice easy trinomial in here, and so we'll set up our x box. Our multiply would be 7, and our add would be negative 6. And the only two numbers that multiply to 7 are 7 and 1. And then to get a negative 6 out of 7 and 1, we'll just make the 7 negative, and these two numbers will work in my add because when I add them together, I get negative 6. However, they do not work in my multiply. They give me negative 7. And double checking my math, it's definitely a positive 7. And so we can't find the numbers. And we can't fudge them to make them work, okay? Therefore, this is not factorable. So now what do we do? So mathematician back in the day came up with this process called completing the square that you can still solve it. And the reason why we can't solve it is because our roots are irrational. They're going to come out to be not nice numbers. And when we factor, we always find nice numbers to work in our X box. All right, so that tells us that not factorable, not rational roots most likely, okay? This is a nice process though because it works on any kinds of roots. So whether they're rational or irrational or not real, completing the square will help you find them. So it's a good process where factoring only works for rational. Okay. All right. So in this procedure, there's a bunch of things to remember, which is why a lot of people aren't a fan of the procedure of completing the square because they have a lot of steps to remember. All right. It's very procedural. So first off, the equation must equal 0, which we already know. All right. But then we're going to go ahead and move the C term over and take out the A term. So it's a little bit tricky to remember that. So we're going to move C, okay, and then we're going to factor out A. So we're going to move C to the right side, okay, and we're going to factor out A from the left side. Okay. So first off, to know, we should know what A and B and C are. Our A value is the number in front of the squared term, which is 2. Our B value is negative 12, which is always in front of the X term. And then our C number is the number by itself, which is 14, just in case you guys didn't know those. All right. So we're going to go ahead and move our C value over until we end up with 2x squared minus 12x equals negative 14. So now our C value has been moved over. Okay. Now we're going to go ahead and take out the A from the left-hand side, and our A is 2. So we're going to factor out that 2 and be left with x squared minus 6x equals negative 14. Okay. So those were two steps that are a little bit unusual to us. We always like to be equal to 0, and in completing the square, we move that C value over so we're not equal to 0. When we factor, we usually factor only equal to 0, and we factor out every single term, and we usually factor out the greatest common factor. And you'll notice I didn't pull x out with my 2, even though x was common. In order to complete the square, you must have a square term. All right. And so, but if you were to take out that x, you would no longer have a square term and you would not be able to complete the square. Okay. Okay, so the next part is dealing with the B. So we move C over, we factored out A, and now it's B's turn. What we're going to do is we're going to identify what our B value is. Okay, we're going to take half of it, we're going to square it, and we're going to add it to both sides. Okay, beware of how much you are actually adding to the left-hand side. Okay, and add the same amount to the right-hand side. Okay, and by doing this, we will be creating a perfect square trinomial. Okay, hence the procedure's name, completing the square, perfect square trinomial. Okay. All right, so we're going to go ahead and say that our b value now is -6. Okay. So this is our b value. Okay, we're going to go ahead and take half of it, which gives us -3, and then we're going to take it and we're going to square it, and it's always going to give us a positive number because we're squaring it. Okay, no matter if you take a positive number and square it, you get positive. You negative number squared, you get positive. Okay, and so now we're going to go ahead and we're going to add it to both sides. So we're going to go ahead and say all of this stays the same, but right here we're going to put the +9 inside those parentheses. Okay. And then we're going to have to do the same thing on the other side. So we have -14, but we have to notice what we actually added. It looks like we added a 9. However, he's in parentheses, so we actually added 18. So we have to make sure that we add 18 to the other side. Okay. All right. So now they're going to tell us to factor the perfect square trinomial and write it as 1 factor squared. All right, so right in here is what they call a perfect square trinomial. So it looks like a trinomial, looks like an easy trinomial, but it's actually a perfect square trinomial. And the reason is if we take it and we do our x box and say multiply to 9 and add to -6, you're going to find the numbers that you find here and here are exactly the same. They're both -3s. Okay, and so what we can do is now we can go ahead and factor our easy trinomial into x minus 3 and x minus 3. Everything else stays the same. You could do a little cleanup here on this side. -14 plus 18 is 4. Okay. Because these are exactly the same, then you can write it as 1 binomial all squared. In fact, you have to, okay, in order to finish this process. All right, so far so good. We're in good shape. Now we're going to go ahead and we're going to actually solve. Okay, and we're going to solve for the x that we have. So very first thing, we got to go ahead and divide both sides by 2 so that these 2's go away and we're left with x minus 3 all squared equal to 2. Then we're going to make the square go away. So we could either raise both sides to 1/2 or we can square root. And in this case, we usually square root. Okay. Because square rooting is an even root and you're doing it to both sides of an equation, we're going to have to remember the plus minus. Okay. And it goes right in front of that square root of 2. Okay. We have one last step. We're going to add this 3 over. And when we do, it goes right in between the equal sign and the plus minus sign. Okay. And so we end up with x equals 3 plus or minus the square root of 2. And these are our answers. So we have to understand there's actually 2 answers in there. Okay, x equals 3 plus the square root of 2, which if you type into your calculator, let's see, is approximately 4.4142 ... All right, that's the decimal value, but that's not exact. This is exact. Okay, and so we want to keep that. All right, our other answer is x equals 3 minus the square root of 2, which if you type that into your calculator, you end up with a long, ugly decimal of 1.5857 ... Again, that goes on forever, and so that's not exact. This one here is exact. Okay, and so there are our 2 roots, and these are the approximations. Okay, about where this quadratic, if you graphed it, would cross the x-axis. Okay, but these here are our actual exact answers. Okay, and you don't have to separate them. You could leave them as 3 plus or minus square root of 2. Don't have to separate them. I was just separating them to show you guys the decimal equivalent so that you could see where that parabola, if you were to graph it, okay, would cross the x-axis. Okay, and I actually graphed it, so just to show you, if you did graph it, it would look something like this, and this one here would be the 1.5-ish. Okay, and here, this one would be the 4.4-ish. Okay, all right. I will see you guys on the backside of notes so we can practice this procedure and get really, really good at it. All right, see you guys on the backside.